Hello, RailGuard. Try again. Take three. I think this. So imagine this is a sleeper on a railroad, and you got them like with every. I think it's 30, 40 centimeters apart. What we do with RailGuard is basically we put a base plate on the rail, and then we put the RailGuard on top in the middle between the two rails on each side. What it basically does is we're using a gyroscope. We're measuring over time if the entire sleeper starts tilting to one side or the other side. The way we measure it is actually using gravitational force, and then we do a kind of like some algebra, calculating it into degrees, so angle of degree tilting. What happens on railroad is when you lay down a railroad, a new railroad or an old railroad, the bedding is super important. Bedding is different in all parts of the UK and all countries basically. So you have soft bedding, you have bedding that picks up a lot of moist during the summer and winter time, and then it basically lifts or lowers the entire track. What the railroad companies are interested in knowing is if it starts to tilt too much to one of the other sides, it basically means you move the gravitational center of the train. So instead of it being center over the track, you basically move it. So it's kind of like it's shifting. That means they have to run the train slower. The way they measure it today is sending out a land survey person to do a laser measurement, and they do that on some sort of regular base during the year, just to check it. What we are offering with RailGuard is real-time monitoring, so nobody have to go on track anymore and do the land survey. The land survey also costs a lot of money, and while they're surveying the track, you cannot run your normal schedule on the track. Like any other business for a railroad company, it's about throughput on the rail system. So the more trains they can run on the system, the more money they're basically going to make. So every stop because of people on the track is basically equivalent of losing money. So track displacement measurement is super important. Also, if you have construction work going on next to the track, it could be building a new highway or building new buildings where they're digging out foundation. There is a risk of destabilizing the track bedding of a track. So that's one thing we're measuring with the device. Then we have the rail itself is made of steel. Steel is different depending on where in the world it's coming from. So you've got Russian steel, Chinese steel, US steel, and European steel. The difference is that steel expand at different temperatures, but it's around 41 degrees. I seem to remember. What happens is basically when you heat up steel, it expands. It's not a lot, but because a rail is very long and it's all connected, there's no way for the tension in the steel to disperse or disappear. So what happens is, in worst case, the track or the rail itself basically expands so much that it rips itself off the sleeper, and that's when you get the what's called buckling of the rails. When rails buckle, well, you can't run on it first of all because you're derailing the train. What they do today is they do visual inspections, so they basically look at the temperature, the ambient temperature, and then they have people that have been in the railroad business for many years. They kind of like have this hunch, gut feeling that okay, now the temperature is so hot outside that we might see some buckling on the tracks. We had a lot of incidents like this summer in all of Europe because we had such an extreme high temperature. We all know that extreme high temperatures during the summer is not going to disappear because it's basically just global warming. People have been warned about it, and now we see the consequences of it. So each RailGuard device is capable of monitoring the track displacement, but at the same time, the core steel temperature in both tracks, which is as important as the track displacement. The whole idea in the future is that if we start collecting steel temperature now, the core steel temperature, and we also collect the ambient temperature, we store that data, and then months ahead from now, we can start looking back at historical data compared to the weather condition in the weather forecast, and then we'll be able to predict if the steel temperature is able to cool down during the nighttime. It's all a multi-factor system where you got steel temperature, the highest day temperature, the lowest night temperature, and then because of the historical data from the steel, we'll be able to see is it getting cold enough during night to cool down the steel enough so it will tomorrow not get even hotter, but actually keep a level of temperature. Prediction algorithms is not a new thing at all. We use it in many different industries. Probably the weather forecast is a one. Weather forecasting is done exactly the same way. They look at the current parameters, they look back in historical data and say, okay, what happened the last time we had these conditions? Okay, this happened. And then the weather guy on TV says, okay, tomorrow probably this is going to happen. So the more data you collect, the more accurate a prediction you can give the customer. And the whole idea is, well, in the future, maybe in a year from now, we will be able to tell them in 2 days from now, the steel temperature is going to be at a critical level on your rail network. So you might want to do visual inspections or lower the frequency of trains on the track, or send a I think it's called boogie out and actually do a visual inspection, or at least inform your customers in advance that maybe we're going to have delays in 2 days from now. So instead of getting notified when you're in the station in the morning, you actually know it maybe 2 or 1 day before, so you can plan for it for everybody. That's a good thing. I spoke to TÜV in Germany, and they are recommending that we put a RailGuard for every 400 meters on the track. And of course, when you're doing real-time monitoring, the more data points you have, the more precise and accurate your data is going to be. That's pretty obvious. But we can't put a RailGuard on each sleeper. So it's kind of like we have to put it in a distance where it makes sense, and we can still collect enough data to process it correctly. So according to TÜV, every 400 meters. I was guessing at every 500 meters, but let's listen to the German guys. The RailGuard itself is made to order, simply because each RailGuard unit is about 1,100 euros in manufacturing cost. It's not a cheap product, but it is a new level of security on rail networks. You might run into people comparing us to a German company called Konux. Konux is making a prediction system for shifts on the track, to see if when they change the shift to going straight and go this way instead, is the engine, there's an electrical engine moving the track, is it actually able to move it long enough the distance? Konux is not a competitor to us, and we're not competing with them at all. But I've been asked this a lot of times in Germany, especially if we're competing with Konux, and we're actually making two different things. One other company I know that is doing it is a company called Rail Monitor. Rail Monitor only measure track displacement. So the railroad companies know about this feature. Rail Monitor basically want to buy our devices and sell them to their customers and pick up the data from our devices and put it into their system. We have had a lot of interest from different countries like Georgia, Cameroon, the Scandinavian countries, India, a lot of different places, Brazil as well. But it's selling railroad equipment it's a long-term sale. It takes a long time. It's complicated, but now you have the basics. The tech inside the RailGuard is exactly the same as in all our other devices, and what it picks up is track placement data, the two rail temperatures, ambient temperature, humidity, and air pressure, TPS location as well.